Well, welcome everybody. Very glad to see you all here. So my name is Javier de la Torre, and we're going to be here talking a lot around Databricks and CARTO and how these two technologies enable a lot of like geospatial use cases. But before we get started, I want to introduce first myself. So again, Javier de la Torre, I'm the founder and chief strategy officer at CARTO. So I've been on the geospatial industry for now, like 20 years. So my background really is in biodiversity informatics, but then kind of like been dropped into to really geospatial and doing species distribution modeling. So that's how kind of like CARTO got started. And now currently also serve on the board of OGC and involved, on things like the standards working group for GeoParquet and many other initiatives. So that's about me. Milos, you're with me?
Yeah, thank you, Javier. Milos here. I'm team lead for engineering here at CARTO since recently, but before that, I've been also working at Databricks for several years, and I've been one of the lead contributors to the subject matter expert group for geospatial Databricks. And my geospatial career is probably a fraction of Javier's in that years served perspective.
Thank you,
But
Milos.
yeah.
No, I'm saying thank you, for making me feel old.
No, that was not intended. But yeah, it does stretch back to my uni days. So I did my bachelor thesis in geospatial, and then also a few years at Barclays in data science domain, and then, as I mentioned, Databricks, and now at CARTO. So very excited about all things geospatial.
Okay, thank you. And today we're very excited to be talking about like CARTO and Databricks because we've done quite a bit of an announcement last week in our Spatial Data Science conference. So we thought it would be great to kind of like get to do an overview of where we stand on this platform. So well, let's get started. So before actually going and covering Databricks itself, just a little bit around CARTO and why we started. As an intro, I mean, CARTO is a modern spatial analytics platform. It allows organizations to analyze, visualize, and develop spatial applications, on top of like very large data sets on the modern data warehouses, which Databricks is definitely one of them, right? So you will have like tools, as you will see, for visualization. We have like to making maps, but also tools for making analysis. So we see now, like the previous one that I showed you, it's more of like how you design this type of like dashboards and maps and visualize data, but also like inside the tool how you can visually design analytics to do a spatial analysis, right? One of the biggest characteristics of CARTO that send it apart, as we will see, is the fact that it's fully cloud native. And what we mean by that is that everything that you do in CARTO, it gets pushed down and it gets processed at the data warehouse, at in this case at the Databricks level. So our goal is always to kind of provide analytics where the data is and not the other way around. And that's what kind of like in a way separate us from the traditional kind of like GIS of working. So we are fully cloud native in that respect. Now, we've already have quite a number of like of customers in many sectors. So I like to say that like geospatial, everything happens somewhere. So you can probably analyze pretty much everything from a geospatial component, and that reflects on the type of use cases and industries that we work right now. So telecommunications, things like network optimizations, like where to deploy infrastructure, very big. But in things like retail, around site planning, transport and logistics, obviously a ton of spatial analytics on it. Public sector is very important. So I'm sure there's a very big difference on sectors if I ask here to the participants, and that speaks to us again how horizontal like geospatial is, and why it's such an ubiquitous like type of analytics. And for us, like in a way, I mean that's one of the things that we want to at CARTO, we're really looking to break, is because we think this is incredible type of technology, spatial analytics, that has been for too long kind of like in a way in a silo. It's been kind of like you had to kind of go to years to school to become like a geographer and to do GIS type of analysis, and you had to use like specialized geospatial tools to work with this type of data. And that we think is a pity, because we think like we should make like geospatial should be much more widely accessible, and this is what we are trying to really achieve at CARTO. And if you look at the history in a way of the geospatial industry in terms of technology, I mean, obviously it started from some very big players, and like towards like the 2010s as one started the move towards the cloud, right, in terms of running GIS in the cloud. But what is actually really happening, and it's actually helping us, to call like break what we call this GIS data silo, is this movement towards the data cloud, or like being towards the data lakes. I mean, there's many ways that you can make this, but like this concept of cloud nativeness and how you can actually do geo in that respect is really what is bringing the opportunity to finally put like geospatial data together with all the rest of data. And that is, from my point of view, it's very, very important. First of all, I like to say that like it just provides better outputs. If you're able to do geospatial together with the rest of all your data in the same tools, you're actually going to finally just get like better insights. It's just combining better your data, either geospatial or non-geospatial. It also, and that speaks towards our goal of democratization, it makes it accessible to a larger number of users, right? So it's no longer the needs of a core GIS department. Also, like very important is it's future proof in the sense of like the latest technologies for analytics do not happen necessarily at the GIS technology vendors. It happens in the broader analytics industry. So for many reasons, we think it's only a matter of time, and we're seeing it already, this huge convergence of GIS and the business analytics. It's just going to happen. And what we're like trying to do at CARTO is to accelerate that from happening as fast as possible. Now, one way to make that happen that I want to highlight here, and we announced it in our conference, is we've been working for quite some time now on the idea of like GeoParquet. How do you bring like vector data to Parquet? That's a very important foundational format, so that you can then rely on the standards analytics formats that you can use on platforms such as Databricks. And last week, we were also very happy to announce that in a similar fashion, we're looking at the standardizing how do you encode rasters on Parquet, but actually not like external links to rasters, but actually the data on rasters directly in Parquet. With, again, one more time, looking at how we can make geospatial data available in the existing analytics infrastructure. And for us, the convenience and the options that opens, to work on it and analyze it together with other data is enormous. So if you're interested on, we call it Rasket, the concept of rasters in Parquet, just let us know, because we're looking, to we get like people using it, trying it. It's based on the way that we handle raster support on platforms like Databricks, and now we're looking, to in a similar way as GeoParquet to make it available and to make it the standard, so that more platforms and everybody can rely on that way of expressing geospatial data on these systems. Now that's on the format side. There's one slide I also wanted to add, because we announced it last week, that I'm very excited about, is we've introduced this concept of CARTO AI agents. So if you're familiar with AI agents, if you're not familiar, they are ways to get AI to resonate, plan, and actually execute actions on top of your data or your application. So we've made, now in CARTO, the possibility to create those AI agents, and it will control the CARTO interface connected to Databricks, and it will be able to understand by looking through vision the maps and actuate and do actions with it. So you can essentially do these maps and use them even without looking at the map. And we think that's pretty crazy, and it's pretty interesting. So if you're interested, we'd love to show you. So with that, I want to finish, before passing to Milos, talking a little bit about, like this partnership that we've had with Databricks, which comes, like for now, I think 3 years since we started working with them, and we've been very excited with them because we've seen like a platform that is committed to spatial data, and especially we've been working with the product managers and the engineering side on Databricks that like is working to provide native spatial support on Databricks. And Milos will talk more about that on the form of a Spatial SQL, which is finally there for us to use. And yeah, I mean, we were going to market with them on bringing like expertise in the form of like how to do visualizations, application development, analytics, geospatial data, but also helping organizations to think about how they can structure their geospatial data on their data lakes. So if that's something that you're interested in, I'd love to hear from you. And Milos, all yours.
Thank you, Javier. So now that we are very comfortable, what CARTO can offer, and I would like to also do a parallel on what is already available within Databricks as a platform from the geospatial perspective. Being that Databricks has been designed as a data and AI platform, so geospatial is just an aspect of the platform. But if you look at this slide, which is quite busy, and it's busy because the reality is very busy. So if you are coming to Databricks as a GIS practitioner, or even as a data practitioner, and trying to deliver a geospatial use case, you have this variety of options. And in some cases, when I was talking with customers in the past, there was this notion of paralysis by too many choices in front of them. So if we start from the left to the right, maybe the most common situation was single node libraries, things that are common in the GIS domain. The things like GDAL, GeoPandas, Shapely. So if you have small volumes of data, you can pretty much deliver a use case very quickly without any additional help. But the moment the data scales, and this is the power of these platforms, is you have that scalability that allows you to not to have the necessity to redesign your applications as your data grows, because the platform will scale for your needs. You need to move into this middle section, where is the Spark frameworks, and then Spark, for the ones that are not familiar with, is the base distribution framework in Databricks, and is what is used to distribute the data across the clusters and make that scalability possible. Now, Spark itself is more of a data platform. It's a generic framework, so it's not very conscious of geospatial data. So to augment it with those capabilities, you may need to leverage other frameworks. So one of the frameworks that back when I was at Databricks we delivered was Mosaic. Not to be confused with AI Mosaic. This was a GeoMosaic package, and that package was adding some spatial capabilities to what Spark can do. Other alternatives are, for instance, Apache Sedona, and there are other packages. These packages give you some veneer on top of Spark and allow you to actually distribute your geospatial use cases. What that has then inspired is product features. These are things that are natively available in Databricks, but are not necessarily available outside of Databricks on an open source Apache Spark distribution. So here what we had for quite a while now is native implementation of H3 functions. There is quite a few of those, a few dozens, and they allow you to index your data against the H3 spatial grid. What is coming soon, and it's now under a preview, is the Spatial SQL, and that will bring your very familiar st_ functions, and about 60 of those. So these functions are fully optimized on Databricks, and they leverage their Photon engine, which is a much faster way of delivering capabilities on top of Databricks. Next slide, please. So what we wanted to do, and what our vision here was from the perspective of integration between CARTO and Databricks, is to clean up a little bit that, make it simpler, and remove that what I call paralysis of choice. So what we provide is a CARTO Analytics toolbox, and you see here in that darker color box is a set of UDFs and set of Unity Catalog register functions and a set of store procedures that you can install within your Databricks workspace and your Databricks clusters. And this layer will actually leverage both Databricks SQL capabilities, the thing that I already mentioned, which are quite powerful and optimal within Databricks, but also when those 60 odd functions cannot deliver, you can extend it with other capabilities, such as, for instance, Apache Sedona, which we bring pre-installed, and we bring many more other things. So we're bringing quad bins and some other store procedures on top of it. The benefit here is that you have a duality, like you have in your current Databricks environment. You can use Databricks SQL for serverless type of use cases where the spatial SQL functions are sufficient. And when they are not, you can use all-purpose compute with our analytics toolbox installed that can allow you to deliver pipelines. I'll show you later a bit how that looks like with respect to workflows, and also combine with some advanced analytics capabilities. We can go to the next slide, please. So how does that fit now in a platform perspective? So CARTO will deliver quite a few other bits. So it's not just that analytics toolbox. That is one thing that unlocks the dual nature of compute on Databricks. But what we bring on top of it is the full PaaS offering, which brings us CARTO Builder for creating your maps, analytics toolbox that they already mentioned, the workflows that allow you to and Javier already mentioned them, but I'll just reiterate, allow you to use UI-driven approach to analytics, so you can actually drag and drop your pipelines, and then we'll delegate those to Databricks jobs. So it's quite a full embrace of what Databricks can offer. And on the bottom line down there, as you're already aware, if you're a Databricks user, Databricks is a multi-cloud platform, so you can get the same experience across the platforms where a Databricks is available. So next slide, please. And it wouldn't be complete the presentation if we didn't have something to showcase. So what you see here on the screen is what we have as a notion of simple tile sets, and in this case, point tile set. So what we will bring into your Databricks environment is some, as I mentioned, these store procedures that allow you to create very scalable data sets that can be comprised of billions of records, but then very, very smooth visualizations and unlock your data for spatial analytics. In order to create these tile sets, all you would need would be an all-purpose cluster inside of Databricks that is Unity Catalog enabled and Photon enabled. Photon is very important here because it brings those Databricks Spatial SQL functions, and Unity Catalog is important because that's where we're going to register some of the SQL native functions as well. And you can run a piece of code that I already have on my screen, and it will basically structure the data so that it's efficient. And on the right-hand side is a preview of how that visualization would look like from the points data tile sets. Next slide, please. Now, if I go further, one of the topics that's been front and center from the Databricks perspective on the Geospatial was the support for spatial indices, most notably H3. I already touched a little bit on the native implementation within Photon, but we are bringing the same capabilities when it comes to H3, but also QuadBin. QuadBin is another grid that is aligned to square shapes rather than hexagons, and it's quite powerful for non-vector type of data. So, for instance, rasters are much more simple to handle when you are indexing them against a square grid than against a hexagon grid. What you see on the screen are massive data set that have been indexed against one of these grids and then stored as tile sets, and this will supercharge any type of analytics that you may want to deliver here. Next slide, please. And going forward, what if the prior data set that has been pre-processed or pre-indexed and aggregated is not enough? Well, CARTO Builder allows you to use Spatial SQL directly next to your maps and produce query-based data sources. And what you see here on it is an example of creating a map using SQL directly in CARTO that gets pushed down back to Databricks, and all of the compute happens in Databricks, and CARTO manages that distribution for you. Through here you will get access to all of those nice functionalities that I already mentioned. Next slide, please. So that's if you're comfortable going using only spatial SQL capabilities. But if you want to, for instance, combine this with machine learning models, you have some custom Python code. What happens then? You can bring the analytics toolbox into your Databricks environment and run the code directly in there. So what you see here on the screen is an example of a SQL query, but it will run in PySpark. It will run pretty much in any language that the Databricks notebooks support, and leverage those functions, and then put them as a step inside of your broader pipeline. And store results, create tile sets on top of those results, and then bring them back into Builder, into other maps. So it's a full back and forth integration between the two platforms in a most seamless possible way that we could imagine. Next slide, please. And as I said, the workflows as I think coup de grace here, which is allowing you to have a visual representation of your pipeline, which is much closer to the way human brain works. Is like I want to take this data set, combine it with this one, it's a join, pass that to this another step, and basically visualize what I'm doing directly inside of CARTO, but everything gets passed back to Databricks and create jobs on behalf of these workflows, and the compute happens in your environment. So and from here you can also schedule these pipelines and etc. And I will hand
Actually,
back
Milos, because we
to
got a
Javier now.
question. Milos, if we get a question around this, actually, since you can maybe talk about the connection of our CARTO workflows with DAGs and Airflow, a little bit on that.
So the workflows themselves are under construction now. So how the DAG will look like in Databricks would be exactly one-to-one. So we will have one CARTO workflow corresponding to one workflow inside of Databricks, where each step in this DAG is corresponding to a step, a task inside of the Databricks workflow. Now, as you know, you're mentioning Airflow as one of the concepts. You can schedule and orchestrate the workflows in Databricks through Airflow. So that's more of a Databricks Airflow integration piece. We here communicate directly with the Databricks APIs and set up those jobs. The benefit of having that one-to-one relationship is the fact that if there is any operation that you have not designed well, we can also directly pass the errors, or if anything happens correctly on the front end, meaning the DAG is logically correct, but the data is not properly partitioned and stuff, you'll know which step is actually the bottleneck of your whole job. So it's quite beneficial from that one-to-one mapping and duality. And hopefully
And if I may add to that, I mean, so to make it very clear, so CARTO workflows is a visual way to make the SQL, or the code that then gets stored and managed in Databricks. So the orchestration and so on is actually something that you do on Databricks. You can register, you can like set things, like schedule them and so on. But when we mean by they're like fully cloud native, it means that we will not be the one orchestrating it. We are essentially a UI in that case to allow you to generate a Databricks workflow, if that makes sense. Great. Next slide. Yeah. Thank you, man. Oh, I didn't realize that. So yeah, take it. Last thing I wanted to show you, because we think, like when we talk to a lot of Databricks users, very often, they're using Databricks to build also like to power applications behind the scenes. So we want to show you also how CARTO platform can be used for that. And for doing so, just want to first open up. Here it is. I want to open up here, you guys see my screen, right? Milos, I'm looking at the right screen, right?
Yes, you are. The application is there. It's just not in full screen, but it shows well.
Oh, okay, cool. Sorry about that. So we just want to kind of go here. This is actually an application that we built, like where data is powered, within, like Databricks. So it's actually a custom application built, that speaks to CARTO, and CARTO speaks to Databricks to get the data. And it's an application showcasing, in this case, a story around raster data, 3D data in the Czech Republic, the importance of vegetation. And you can see, like we're powered by DeckGL, the open source DeckGL library, which we are like one of the biggest contributors, and that allow us to have like some very, very neat visualization and embedded on your own application. So I just want to show you an example of an application built in here. Again, powered by datasets stored in this case. So you see here, I'm showing buildings. These are actually vectors. I can do this. Some of these options comes directly from the data warehouse, and in other cases, like it's operations that you do client side, but it's a lot of like capabilities, to design, like your own custom applications. And the way that you do that, and you got it here for that, is using Builder, the application that like Milos was showing before. You can design the visualizations, and then those visualizations you can use them on your code using DeckGL to load those layers those visualizations into your own application. So you just pass away the map ID of a CARTO that the map that you made with a CARTO builder, and then that's how you can integrate them on your own code. And that means that if you have like a very large data set that you want to visualize on your own application, this library with DeckGL. And so what it allows you is to kind of like it takes care of loading the data progressively in tiles, so you can handle any size of spatial data. So that's for the developers experience. So I think like that's it from the things. It was a very short one that we wanted to show you. But if any of you are coming to the Data Plus AI Summit in San Francisco, I think it's in 3 weeks now. Milos and I will both be there. And we also have a booth that you're very welcome to come and pass by. And I think there's at least 3 or 4 sessions that like where like CARTO and Databricks together are kind of going to be highlighted for application development, for analytics, for different kind of like purposes. So if you're interested, you just follow our blog, and you will be able to kind of like we'll put like all the details about all the sessions, and of course we'll be there to kind of like to talk to you if you're around. I think that's it from what we wanted to show you. I don't know if there's any more questions. I've been making questions as we were going, but I don't know if there's more questions. Let me see. No, there's Q&A. I don't think there's. I've answered a couple of questions around. One was around questions around storing rasters and this Rasket versus kind of like a GeoTIFF or cloud optimized GeoTIFF. So I talk about like how the performance right now is equivalent, and in some cases actually much faster because obviously the parallelization capabilities of Databricks, the Spark ecosystem. The other question was around, I think around the availability of data. So we didn't talk about it, but CARTO also hosts a big, large, more than 10,000 data sets, from demographics, human mobility, weather. We already publishing some of those data sets as delta sets. So again, with our objective of being as cloud native as we can on Databricks. So if you're looking for data on the Databricks ecosystem or spatial data, we can definitely help you in that. And there's actually a very interesting announcement coming around also with Overture data, which we've already brought to other platforms. So yeah, and I think those were the 2 questions.
Yes, they were. I would just add one thing around the comparison between COGS and, for instance, Rasket. The reason, so there are many optimal formats for raster across different spatial domains. If you think about COG when you talk about imagery, but when you think about multidimensional arrays, probably ZAR is going to come up, or NetCDF. The difference in the approach of Rasket versus those is we are bringing GIS into the data concepts versus the opposite. So what we want to do here is actually build a thing that is data native as opposed to GIS native. So because that will make interoperability and also all of the the fair concepts that come with it findable, accessible, interoperable, reproducible, more easy to achieve. Then with managing blob type of formats on top of your lakes. So think about something warehouse native versus something data lake native. Data lake, of course, can treat blobs, but think about something that's more structured. So bringing that unstructured domain into the structural world, getting the benefits of both. That's the idea.
There's another question that maybe we didn't make very clear, so I'm glad that you make it from Gianfranco. I have missed when will the geo functionalities be available in Databricks if not already there? So let me answer that. As you've seen, CARTO relies on Databricks on this new set of functions that are photon accelerated called Spatial SQL. That right now is in beta, and if you're interested on accessing them, you can request access to start using them. So that's number one. Then on top of that, there's the CARTO Analytics Toolbox for Databricks, which is also in beta on our site, and you can also kind of request access to talk to us about it. So the beta on the Spatial SQL has been already for quite some time, and there's still some things like that might be missing in terms of like storage and certain things. But overall, I mean, like most of the pieces are already there, and we're already using them, leveraging them with customers. So yeah, it's about getting on the betas, but they're already available. Great. Well, I'm just getting here that, we only had half an hour prepared for this, so I'm gonna kind of wrap it up here. Like our contacts, I quit the connection, but, like I'm sure you can find us, like on our website on contact@carto.com. We'd love to hear what you think, or if you got any further questions, we'll be very happy to assist. We think there's a huge opportunity when it comes to modernizing geospatial and GIS in Databricks. And we think, there's going to be many organizations kind of like finally doing this convergence of GIS with the rest of analytics. And we hope to facilitate that. So thank you very much to everybody for assisting. Talk to you soon. Bye-bye.
Bye-bye.